Okay, let's do some more fun Lorentz transformation examples just to see how this works. Let's say that we're in frame O and we've got two events. The two events are going to be designated by coordinates, including a time, right? So the first event happens at 0 meters. So I didn't have it happen at the origin, but my origin here maybe isn't 0 meters. So the first one, the first event happens at x1, and the time at when it happens is t1, and it happens at y1 and z1 equals 0. We don't worry about those. Let's just do one mention. And let's say we have a second event that happens down the road. Say it happens 6 times 10 to the 8th meters down the road. That's all right. That's 600. It's just to make the numbers nice. I made a large x. You'll see why. 600 million meters away. That's all right. But the second event happens at x2, and that happens 1.5 seconds later. And we're not worried about y and z. We're just happening in one dimension. So this could be something as simple as I'm in my house at t1 equals 0, and I get out of bed. That's my first event. I get out of bed. And the second event is, I get into my car that's traveling at close to light speed velocity, and I arrive at work, which is 6 times 10 to the 8th meters away at 1.5 seconds later. Okay? Might not sound terribly realistic. But it could also be the first event is at t equals 0, I get out of bed. The second event could be, I don't know how far away the sun is, I can't remember, but let's just pretend it's 600 million meters away. I think it's a lot more than that. But anyway, 600 million meters away. Let's say the first event is me getting out of bed at t equals 0. The second event is that there's a storm on the sun at 6 times 10, or a storm on some place in the universe that's 6 times 10 to the 8th meters away from us 1.5 seconds after I get out of bed. In other words, the two events don't have to be connected in any way. This is just the time and distance between two events. And we will talk about this later, that the two events could be causal, meaning that they are connected, or maybe they're not causal. They have nothing to do with each other. And this could be, we're lecturing in a classroom, and at some moment you're listening to my lecture and you drop a pencil, and then I'm lecturing at the board and I turn around, right? So those are two events that happened separated in space and in time. And the question is did I turn around because you dropped your pencil, or did I turn around because I was going to turn around anyway, right? But those are still two events. They might be connected causally, they might not. Okay. So anyway, that we've got two events that happen at some position and some time. So then we ask, what is the velocity of frame O prime where these events happen 1 second apart? In other words, is there an observer who will watch these two events in some other frame of reference and see these two events happen 1 second apart? The answer may be that there isn't, but we will have to figure it out. What is the velocity of the frame O? Either it's got I couldn't think of the word, a finite velocity that is less than c, or it's got a undeterminable, like a velocity that, that's either imaginary or greater than c. If you calculate a velocity greater than c, that is impossible. It is important for us to understand from this point that v greater than c is impossible, that c is a speed limit. Not only is c the same in all frames of reference, it is also a universal speed limit. Nothing can go faster than c. Okay, so how do we answer this question? Well, we can draw a pretty picture, right? We've got the events in frame O, and we've got O prime, which is moving at speed v. We can write down the equations that say that delta x prime is equal to gamma delta x minus c delta t, and delta t prime is equal to gamma delta t minus v over c squared delta x. And we can identify our variables, right? So this is very much like any kinematics equation. We draw a picture, we write down our equations, and we write down what we know and what we don't know. Well, let's just start from, we know that delta x prime is, we don't know what delta x prime is because that's in the O prime. delta t prime, we say, well, delta t prime, I did a double prime again. Delta t prime is equal to 1 second. Gamma, that's unknown. That's sort of what we're looking for. We're looking for the speed. What else? Delta x is equal to 6 times 10 to the 8th meters. And delta t in the unprime frame, delta t is 1.5 seconds. And that, and v is an unknown, but v and gamma are related. If we find one, we find the other. So those are the knowns and unknowns. So there are really two unknowns, and 2 equations. So we should be able to solve this because there's 2 unknowns and 2 equations, right? There's not 3 unknowns because gamma is in terms of v. So I just realized that the question I asked makes the algebra really messy, like unnecessarily so at this point. So let's instead ask a slightly easier question. And let's ask the question, is there a frame of reference in which these 2 events happen 0 seconds apart? In other words, also, what does it mean for 2 events to happen 0 seconds apart? That means they happen simultaneously. Is there a frame of reference where these 2 events happen simultaneously? And so now our delta t prime is not 1 second, but is 0 seconds. All right, let's see if there's a frame and what it is, if there is. So we want to just go ahead and plug in to the time transformation because we know the time in the 2 reference frames. So that's why I'm going to use the time transformation instead of the position transformation, because we know the times in the 2 reference frames. 0 equals gamma times delta t, which was 1.5 seconds, minus v over c squared times delta x, which was 6 times 10 to the 8th meters. So from that equation, we know everything except for the velocity, right? Because the velocity v is both built into gamma and the v over c squared term. So let's go ahead and simplify that. 0 equals gamma times 1.5 seconds minus v over c times 6 times 10 to the 8th meters over 3 times 10 to the 8th meters per second. All right, so I have a v over c term here now. That's nice to write things in terms of beta. And so I can go ahead and write this out. 0 equals gamma times 1.5 seconds minus beta times 2 seconds. And so now we solve for beta or v. Therefore, so this means that 1.5 seconds equals beta times 2 seconds, and therefore beta is 1.5 over 2. 1.5 over 2. The units, it's a unitless quantity. And so beta is 0.75. Now remember, always think about whether your gammas and betas make sense. Beta should be a number between 0 and 1, and it is. So this just means that therefore v is equal to 0.75 c, since beta is v over c. V is 3/4 of c, and you could obviously write that out if you wanted as a number. So what does this mean? This means in a frame of reference that is moving at v equals 0.75 c, it sees these 2 events happening at the same time. In my reference frame, I got out of bed at x1 equals, at t1 equals 0, and then a second and a half later, something happened on the sun. According to the frame of reference moving at 0.75 c, that alien sees the 2 events happening at exactly the same time. Because then there's a question of, so can these events be causal? Could it be that my getting out of bed made a storm occur on the sun? And the answer is, if they could happen simultaneously, then they could not possibly be causal. Because in order for something to be causal, the second event has to communicate with the first event. Or the first event has to communicate something to the second event before the second event can happen. That's what causal means. But communication cannot happen faster than the speed of light. Communication cannot happen between 2 separate events simultaneously. It must happen at some time later. in order for light, the fastest communication is light. Light cannot get there in t equals 0 seconds. So these two events cannot be causal. That wasn't asked to begin with, but whoops, that you don't need that. Can't be causal because delta t prime equals 0. That means that they're simultaneous in some frame. If they're simultaneous in any frame, they can't be causal. Physics still has to work in every frame. And if light cannot be communicated from one to the other, then they can't be causal according to the one frame in which they're simultaneous. So they can't be causal in any frame. That's interesting. So that means that for any two events, it doesn't mean that there is a frame of reference for which delta t equals 0, right? So when I asked this question, I said, actually, is there a frame where the two things happen 0 seconds apart? Because if they're causal, there is no frame where they happen 0 seconds apart. And what we would have found when we did the math is we would have found that the frame had to travel faster than the speed of light, and nothing can travel faster than the speed of light. Let me just show you that, right? Let's just say that we have two events that happen in the lab, or, on the track, 100 meters away. So let's say that at x equals 0 and t equals 0, I shoot the starter's pistol on the track. 100 meters away, somebody's standing at the finish, and they're so shocked by hearing the starter's pistol that they drop their clipboard 2 seconds later. Well, it probably wouldn't even be 2 seconds later. Or I shoot the gun at t equals 0 and x equals 0, and somebody standing at the finish line at 100 meters, they hear me shoot the gun, and so they're like, ooh, I got to get ready, and so they go and they pick up their clipboard 2 seconds later because they heard me shoot the gun. Those two events are causal. They're causal. Definitely causal. I mean, or at least they could be causal, right? It could be two completely arbitrary events that aren't causal. So then we ask, is there a frame O prime in which delta t prime equals 0? Is there a frame in which those two events are simultaneous? So we go ahead and we solve in the exact same way, and what do we find? We find that beta is, in this case, 6.7 times 10 to the 6th. Okay? Okay? Is that okay? No, that's not okay, because remember, beta is always less than 1. Always less than 1. 0 is less than or equal to beta, which is less than 1. So that is not possible. So that means that since that's not possible, the two events could be causal. Or there is no event, and there is no frame of reference in which they're simultaneous.